student, welcome to Install video lecture series for maths. We believe in democratizing education for all. Today we are going to learn a new chapter, that is real number. Come on, let's get started. We already know about the natural number. Natural numbers are the numbers that we use in counting, right? So when we count, we always start with 1, then 1, 2, 3, 4 and so on. Next we have the whole number. Whole numbers are the numbers, natural numbers with 0. So it includes 0 in natural number set. So a natural number set is denoted by script N and whole number set is denoted by script W. And then we have integers. Integers are the number set in which it contains the whole number and the negative of the natural number. There we have -3, -2, -100 and so on. It is denoted by script Z or script I. Next, we have the rational number set. So rational number are the numbers which can be expressed in the form of P by Q, where P and Q are both integer but Q cannot be 0. The denominator cannot be 0. Now here we have 1 upon 2. 1 is the the numerator, which is P, and 2 is the Q, right? So it is in the form of P by Q, right? Same for the 2. 2 you can express that 2 upon 1, right? Therefore it's a rational number. So looking at this, okay, we have another set which cannot be expressed in the form of P by Q, which is known as the irrational number. So irrational numbers are numbers that cannot be expressed as what the ratio of two integers. So like pi, usually people say pi is equal to 22 by 7. It's not correct. It's approximately equal to 22 by 7. So pi is irrational number and root 2 is also irrational number. So decimal form of this irrational number we'll see in the coming slide that it has non-repeating and non-terminating decimal representation. Okay. So moving ahead, we can represent the number system. Okay, first set is the natural number. If you add 0 in it, we get a bigger set, which is a whole number which contain the natural number. Then we have integer, right? Integer we have which contains the whole number also and the natural number also. And then we have a bigger one, that is rational. So rational we have, it contains integers, whole number and natural number. So we can ask a question like this also: is every rational an integer? But not, because there are few in this rational number here which is not contained in the integer set. Similarly, we can ask the question like, is all whole numbers are natural number, right? That or you can go in opposite way also, is all integers are rational? Yes, in rational set we have the integer set. So this is the representations of the rational number, right? So decimal expansion of rational numbers, it has a terminating expansion. Terminating expansion means division stop, means when you divide 5 up by 2, we get 2.5, okay, and the remainder is 0, right? Such type of representation is known as terminating decimal representation. You can have the example like 0.75. Here after this, right, the numbers are not there, it means terminating. It has proper fixed value. Next we have non-terminating repeating, which is also known as recurring. Like suppose if you divide 2 upon 3, we know that 0.6666, it's repeated infinitely, right? So such type of decimal representation is known as non-terminating repeating, which is also known as recurring. Such type of numbers, that is 2 upon 3, are also rational number, but decimal representation is recurring. And here we have another example. 5 upon 2 is also rational number, right? It has a decimal representation, terminating decimal representation, right? So these are the two main types of decimal expansion of the rational number. Next we have the irrational number. Irrational numbers are numbers which are not rational, which is also considered as a complement of rational number, as you know about the set, right? So if we take the complement, means not rational numbers are known as the irrational number. So when we express it we get it as non-terminating and non-repeating. That is non-recurring. That is, suppose if you have 1.01, 002, 0003, we don't know which number is going to come. It may be 7, 8, 9. Okay, it's never end. It means what such type of numbers are known as non-terminating, non-repeating, that is non-recurring. Real number is the collection of both the rational number and irrational numbers. So together, okay, we have the number set which is known as real number, okay, which is denoted by script R. Now let us learn one important theorem, okay, which is known as Fundamental Theorem of Arithmetic, which says that every composite number can be factorized or expressed as a product of prime, and the expression is unique, okay, apart from the order in which the prime factor occurs. It means, suppose 6 is a composite, we know, because it has more factors, okay, it has more than 2 factors, so 6 can be expressed as 2 into 3. We are talking about the prime factorization, not any other factorization, because 6 can be expressed as 1 into 6. This we are not considering as of now, okay, we are considering the prime factorization. So for any number, it is unique apart from the order. Means you can write this as 3 into 2 also, but it is same, right? The order doesn't matter. But for 6, every time you will get 2 into 3. You will not get any other prime which gives 6. So that is nothing but Fundamental Theorem of Arithmetic. Okay? For 30, 2 into 3 into 5, or else you can write 5 into 3 into 2. It will be same. For any composite number, it will be unique. That is a unique prime factorization. Okay. So let's take the example now. Suppose if you write 10, 10 can be expressed as 2 into 5, right? Because we are doing this factorization. Okay, like this. Understood? Now if you have 20, you will have 2 into 2 into 5. We are expressing as a product of prime. You can express this as 5 into 2 into 2. That's unique. Okay, if you calculate, your answer will be this only. If I calculate also, you will only get this. Means 2 will repeat 2 times and 5 will repeat only 1 time. 5 will repeat only 1 times and 2 will repeat 2 times. Next, let's understand about the HCF. We already know this, right? HCF is nothing but highest common factor among all the factors which is common to both, or if you have 3 numbers, we are going to take the highest number. Means it is also known as the GCD, which is also known as greatest common divisor. It is the largest positive integer that divides the given numbers. Okay, so let's see the example. So the list of factors of 12, we have 1, 2, 3, 4, 6 and 12, right? And factors of 16, we have 1, 2, 4, 8 and 16. Among this, the common factors are 1, 2 and 4, right? So from all this common factor, we have 4 is the what? 4 is the highest. Therefore, 4 is known as highest common factor. Now let us understand about the LCM, which is also known as lowest common multiple. Lowest common multiple means among all the multiple, we are going to take the lowest value. Okay, so here when we divide it by the numbers to the LCM, we will be getting 0 in it. It means it's a multiple. Now let's see the example here. We know that the multiple of 4 is 4, 8, 12, 16 and so on. And multiple of 5 is 5, 10, 15 and so on. We have the common multiples like 20, 40, 60 and so on. So among all this multiple, we have the smallest multiple, that is 20. So 20 is known as the LCM. Okay. Now let us learn the prime factorization method. What is mean by prime factorization method? Prime factorization method is the expressing of a number as a product of prime. That's it. So for that, what we are going to do is, we are going to start dividing with a prime number. For this, you should know the divisibility test of the numbers like 2, 3, 5, right, and 7 and 11, the small numbers you can take. So first we'll start with a prime number, then divide it and then keep dividing by taking in another prime, okay, and then you will get a list of prime which divide the number. After that, we'll express that number as a product of this prime. So we'll see one example. So now we have prime factorization of 12 and 16. So 12 as an even number, you can see that it can be divided by 2. So when we divide by 2, we have 6. When we divide by 2, we have 3. So 12 can be expressed as 2 into 2 into 3. Okay. So here we get the last prime numbers. So we have 3. Okay. 16. So we have 2, 8, 2, 4, 2, 2. See, some people used to divide this again by 2 and make it 1. We sometimes write 2 and 1 here and we stop the division. There also we'll get the same answer. Previous also we were getting 2 into 2 into 2 into 2. Here also we'll be getting 2 into 2 into 2 into 2. So this is just a extra step. Okay. So 16 can be written as 2 into 2 into 2 into 2. So this is the prime factorization of 12 and 16. Okay. Next, we are going to do another prime factorization, 4 and 5. 4 we have 2 and 2. So we have 4 can be expressed as 2 into 2, and 5. For 5, we know that 5 is a prime number. So we are going to express this as 5 is equal to 5 into 1. But there we have one number which is not a prime. Okay. So we cannot express 5 as a product of prime number. Okay. Now let's recap what we have learned in this video. In this video, we have learned the number system of natural number, whole number, integer, rational number and irrational number. Decimal representation of rational, it includes the terminating, non-terminating and repeating, which is also known as recurring. But for irrational number, we have learned that it has a non-terminating, non-repeating, that is non-recurring decimal representation. Okay, not only this, we have learned the fundamental theorem of arithmetic and LCM and HCF and prime factorization method. So I hope you have thoroughly understood the introduction part of this chapter, real number. Keep watching our install video. Thank you.